Today I will be giving a little bit update about the phase feeding of sows in gestation and lactation. I presented a part of this study in Midwest meeting, but I have some update data, so follow through me. As we know that sow reproductive performance has been steadily improving for some time. This figure from USDA shows that the sows in early 90s used to produce somewhere around 8.05 liters per sow. Now this has increased up to 10.1 liter rate. This is because we are selecting the sows for larger litter size and higher milk production. Here we can see that the milk production of sows in early 30s used to be around somewhere 3 kilograms per day. Now the modern sows can produce somewhere around 12 to 13 kilograms per day of milk. However, we are also selecting the sows for lean genetics. So this makes it very challenging to manage and feed these highly productive sows. So this asks for the need for continuous feeding assessment of these sows to fulfill their nutrient requirements. The nutritional status of the reproductive herd can affect the total production profitability. Gestational nutrition prepares the sows for successful reproduction throughout their lifetime. As gestation progresses, sow will shift from recovering from their early gestation and from early gestation and also to build the fetal for the next cycle. This figure, adapted from NRC 2012, shows the predicted total protein gain of second parity sows during gestation. Here we can see that the major protein requirement is for protein deposition, which is dependent on time, and energy dependent protein deposition. However, the energy protein requirement for the fetus and the total conceptus and the memory part increases in late gestation. With that pattern, NRC has formed this graph where we show the SID lysine requirement of sows throughout the gestation. Here we can see that from early gestation to late gestation, the increase in SID lysine requirements is twofold. However, when we look at the energy requirements of gestating sows, we see that the most portion of the energy requirement goes to the maintenance and maternal gain. There is a slight increase in the energy requirement from early gestation to late gestation, which is somewhere around 30 to 35%. So the lysine requirement goes twofold, and these energy requirements is just 30 to 35%. So as a normal practice, we feed sows a same diet or increase the step of feeding system in gestation. So this might not address the total requirement of amino acids in late gestation for these sows. So some researchers show that feeding a single gestation ration may lead to overfeeding in early gestation and underfeeding in late gestation. During late gestation and early lactation, we know that sow often becomes catabolic and starts to use their protein and fat reserves from their body for supporting the piglets. If this condition is extended for a longer time, it might affect negatively for the longevity and productivity of these sows. As we know that after farrowing, the milk production of the sows increases gradually, and it peaks around 3 to 4 weeks of lactation. As milk production increases, the demand for lysine also increases. This figure, adapted from Dorman et al. 1998, shows the lysine requirement for liter weight gain. In this paper, Dorman compiled 9 different studies to make this equation, where the 4 studies were he estimated crude lysine requirement for liter gain using 0 muscle weight loss, and crude lysine requirement for liter weight gain using zero corrected nitrogen balance. And this figure, from this figure, we can see that as the liter weight gain increases, the crude lysine requirement for the sows also increases. And also, with some recent researches from Crystal and Dr. Crystal and Dr. Samuel, we can see that recent studies have suggested that amino acid requirement in the sows may be lower than estimated in early gestation, and maybe it could be higher than in later gestation. However, those are the estimates based on nitrogen retention studies and some other methods. However, we don't know if this response criteria will show in performance in terms of liter weight, liter size, and sow production, reproduction performances. So with that, we hypothesize three-phase sow feeding program, where the total entire gestation is divided into three phases. Phase 1 goes from 0 to 35 days, phase 2 from 36 to 70 days, and phase 3, 71 to 109 days. In lactation, those phases are from 0 to 6 days, 7 to 12 days, and 13 to 18 days. These phases are based on lysine level, and they are balanced for essential amino acid from NRC 2012. We hope this would provide the essential amino acid and other nutrients at appropriate time for appropriate function. With this, the objective of this study is to evaluate the effect of phase feeding lysine to multiparous gestating and lactating sows during the period of gestation and lactation. So the specific objectives of this study, this is an ongoing study. So we have some objectives that has not been achieved yet, but the specific objective of the study will be to see sows and liter performance, plasma metabolomics during the period of gestation and lactation, and piglet growth performance and robustness through nursery phase. However, today I will be only talking about this sow and liter performance, as the other work is still going on. This experiment is performed at Southern Research and Outreach Center at Waseca, University of Minnesota. This is our swine research facility, where we have gestation stalls over here, we have gestation group pen, and we have 16 farrow rooms here. This study starts with the lactation 1, or phase feeding in lactation 1. We rebred those sows, it goes to gestation, and then we use the same sow for lactation 2. Moving on to materials and methods. We use 177 multiparous sows from parity 1 to 6. We divided those two sows equally. Those sows were blocked by parity, and they had similar back fat and body weight. The sows in phase feeding regimen will get 0.8% SID lysine diet as on phase 1 of lactation, 1% SID lysine on phase 2 of lactation, and 1.2% SID lysine on phase 3. The sows on control diet will get 1% SID lysine throughout the gestation, throughout the lactation. After weaning, the sows will be rebred, and those sows who were in phase feeding in lactation will go through phase feeding in gestation. The sows on control in lactation went to control in gestation also. Phase 1 gestation, sows got 0.4% SID lysine. Phase 2 sows got 0.57% SID lysine. And phase 3 sows from day 71 to 109 get 0.7% SID lysine. And control sows got 0.57% SID lysine throughout the gestation. Here the amino acid in both lactation and gestation diet was made as a ratio of lysine according to NRC 2012. So we measure the sow's body weight and back fat at the start and end of each phases. Liter weight were measured within 24 hours of birth and at the end of each phase. Sows are housed in stalls from breeding up to day 35. Then we did a preg check on it, and then we moved the sows to gestation group pen with electronic sow feeder where they stayed for 109 days, and then the sows were moved to farrowing rooms. For statistical analysis, we used mixed procedure of sows. We used general linear model with position distribution for the counts, like mummies and stillborns. Individual sow and litter were experimental unit, and significance were declared at p-value less than 0.05. Okay, moving on to the results. First, let me explain a little bit about the title and the lesions. The blue bar or the line will represent the control treatment, and the red will represent the phase feeding regimen. The x-axis will represent the time of measurements, and y-axis will have the response of our criteria of interest. In this figure shows the effect of phase feeding versus control on sow feed intake during lactation 1. Here we did not see any difference between the feed intake among the treatments on all the phases and total feed intake. This figure shows the effect of phase feeding versus control on sow's weight change during lactation. Here also we did not observe any difference among the dietary treatment. Similar for the sow's backfat change, we did not observe any difference in backfat change during the whole lactation and within the phases also. Similarly, while looking at the effect of phase feeding versus control on litter weight in lactation, we did not see any difference for the litter weight gain or the total litter weight in the end of the lactation. The dietary treatment did not affect the number of pigs weaned, neither did it affect the survivability of pigs from birth to weaning. Also, we did not see any difference in return to estrus from among the treatments for the sows. As moving into gestation, during gestation feeding also, we did not see any difference in sow's weight change. Similarly, no difference was observed for sow backfat change during the whole gestation or within the phases also. The sow's dietary treatment did not affect the feed intake in either of the phases or the total feed intake through the entire second lactation also. And similarly, we did not observe any difference in the weight change during lactation 2. Same thing with sow's backfat change. We did not observe any difference with among the treatments in sow backfat change. No difference was observed for litter weight gain in lactation 2. So similarly, we did not observe any change in number born alive or the number weaned among the treatments. Similar for number of mummies and stillborn were not different among the treatments, and the survivability for birth to weaning was also not different for both treatment groups. We did not find any difference for return to estrus interval also. In summary, feeding multiparous sow with low SID lysine diet in early gestation, that is from day of breeding to 35 days, had no effect on sow body weight and backfat change. Feeding high SID lysine diet in late gestation, that was from day 71 to 109, did not influence the performance. So after that, we calculated how much SID lysine intake our sows ate, how much lysine. And then we got this figure from NRC, the predicted lysine requirement for our sows that were used in the study. And this blue line represents the sows that were in phase feeding, and yellow line represents the sows that were in control diet. They ate slightly higher than NRC predicted. Similarly, in lactation also, this blue line represents these sows on phase feeding. Yellow line represents the sows on control diet, and the red line is the predicted SID requirement from NRC 2012. feed intake during lactation phases and total feed intake also was not affected by our treatment. Neither litter performance nor sow body change and back fat change was seen to have effect on by our treatment. Sows on either treatment maintained their body weight during the lactation. However, we saw decrease in back fat during the lactation. In conclusion, phase feeding multiparous sows based on lysine level during lactation and gestation did not affect sow and litter performance in our experimental condition. However, to interpret that, we have some ongoing research going on. We are looking for plasma metabolomics during the period of gestation and lactation, which would be related to amino acid metabolism. We did some nitrogen balance study during lactation, but I don't have data for now. And we are also looking for piglet growth performance and robustness through the nursery phase. For that, we will be looking at muscle characteristics at birth, and also we'll challenge nutritionally and immunological challenge to the piglets to see the robustness of pigs.